Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit and we are discussing the different components of electronic circuits. Means we are discussing the various electronic components which are used in development of the electronic circuit. In the today's lecture we discuss the one of the important gadget of the electronic circuit, that is used as a wide range and for the small instrument to the larger instrument. The topic of today's lecture is the light emitting diode, that is also known as the LED. Nowadays we use these LEDs in our homes. So these LEDs, what are these LEDs, how it works, we will discuss in today's lecture. First, the light emitting diode, or the simply we call it as LED, are among the most widely used all the different types of semiconductor diodes available today. Means these light emitting diodes made up of diodes, that is a semiconductor diodes, and commonly used in many electronic appliances. Some of the examples are TV and the color displays. You are seeing on the screen that this is the common LED we use in our daily life. Now what is the LED? The diode which emits the light during the conduction is known as the light emitting diode. It means when the diode is conducting, then it emits the light, then that emitting diode is known as the LED. Now how it works? It works on the electroluminescence principle, in which the semiconductor materials emits light. Means we make the semiconductor material in such a manner, or we process, or we connect the semiconductor materials in that manner so that it can emit the light when placed under the influence of the electric field. So this is the LED, light emitting diode. You commonly you always see this type of LEDs in any instrument. As we use the voltmeter, ammeter, then a red light is blink, that is the diode, that is the LED. And you see on the screen that LED is having the epoxy lens that cover up anode wire and cathode wire. Positive and negative terminals are here, and here is a flat spot on the LED. You see clearly, you can see there is a 2 point, one is cathode and one is anode. When the electric current is passed, then it emits, so it is a LED. What is the definition of the LEDs? As we know that when the diode emits the light, when it will be conducting, then that will be the emitted diode, or we can say light emitted diode, that is a LED. It works on the principle of photoelectroluminescence, in which the semiconductor materials emit light when placed under the influence of the electric field. Now we can see that the LED is as similar as the diode. You see on the screen that we are having the symbol of LED, and this is just clearly near to the symbol of the diode, as a diode symbol, except for the two small arrows that specify the emission of light. With the diode symbol, we are having the two arrows outside that represent the emission of the light. So it is called the LED, a light emitting diode. The LED includes the positive terminal, that is the anode, and one of the negative terminal, that is the cathode. You can see clearly that here we are having a anode and cathode, and the two arrows represent the emit of the light. Now what is the LED and how we can define the LED. So LED are promising light whose efficiency is 10 times greater than that of the incandescent lights that we are using in our houses. So nowadays all incandescent light replaced by the LED, as it uses very less power and the cost of the electricity is very less. So nowadays we use the LED. So it is a long operating lifetime, and reliability has made LED as potential choice for the next generation lighting system, that is used in the automobiles, emergency backlights, and doors and outdoors. So LED light can also be referred as the solid state light. conducting, that is a SSL, that based upon the solid state technology, that because we are using here the semiconductors, that's we are using the semiconductor devices, so we will call it as a solid state lighting state system. So LED was the first discovered in 1960, and its characteristics decide this light source is suitable for indication, not the illumination. That time that LED is used only for the indication purposes, because the power of this light is very less. Now LED is quite effective and efficient for colored light applications. With not only the white light, we can get the colored light by using the LED, by changing the different semiconductors. So we can get the colored light by using the LED. Unlike the conventional signs and signals, which use the normally white light sources and the colored glass or the plastic filter or the lens to create the sign or signals, color LEDs required no filtering, no glass, no plastic filter we use, but the semiconductor we choose in such a manner so that it can emit the colored light. So in case of the LED, we use no filters to get the colored light. The light absorbed by the filter in the conventional product is essentially wasted, and because of this waste, the luminance efficiency of the LED signs and signals is often higher than that using of the conventional light. So on what principle it works? It works on the electroluminescence principle. So what is this electroluminescence? It is an optical phenomena and the electrical phenomena also, because we are giving a light and the optical output we are getting, where a material emits light in response of the electric current passing through it. So when we apply the electric current and we conduct the diode, and it will emit the light, and that's why it is a optical as well as the electrical phenomena. That's why it is called the electroluminescence. So now LED works on the principle of electroluminescence, that we have to remember. So on passing a current through a diode, minority charge carriers and the majority charge carriers recombine at a junction, that we all know. Then we get the depletion layer. On recombination, the energy is released in the form of the photons, and that photons emit the light. As the forward voltage increases, the intensity of light increases and it reaches to the maximum, and we get the maximum output through these LEDs. So on passing a current through the diode, minority charge carriers and the majority try to recombine in the depletion layer. On the recombination, the energy is released in the form of the photon. As the forward voltage increases, the intensity of the light increases and reaches the maximum. So the LED first developed in mid 1990 and have made LED illumination system feasible for some applications, like number of products it was available in the market for the not for the luminescence purpose but for the indication purpose. At present, that typically we get the indicator LEDs have light output in order of the one of the several lumens. So where the LED illumination produced on the order of tens of hundreds of lumens. So nowadays we use this LED for the luminescence purpose also. What is lumens? That is denoted by the 1 mu and are measured of a total amount of visible light to the human eyes. And the lamp or the light source, the higher the lumen rating, the brighter the lamp will appear. It means the lumen power should be high, the value of the lumen is high, then the output will be the brighter. As the LED technology revolutionized the lighting industry, so it's important to understand how an LED source works. So what is the LED? Now we see that it is a semiconductor diode that illuminate. So electronic device that permits the current to flow in only the one direction. The diode is formed by bringing the two slightly different materials together to form a PN junction. As we know that the diode made up of the P type and N type of material. So here also we use the P side contains the excess of the positive charge indicating the absence of the electron, where the N side we are having the holes that contains the negative charges, and the less number of the holes. So electron is simplified PN junction diagram, we can see in the diagram further. The light emitting diode is a two lead semiconductor light source. Because why it is a two lead? Because we are having a PN junctions here. So in 1962 Nick Hornick has come up with the idea of the light emitting diode and working for the General Electric company. And he explained the light emitting diode is a special type of the diode, and they have the similar electrical characteristics to the PN junction diode. LED allows flow of the current in the forward direction and blocks the current in the reverse direction. So LED occupy a small area which is very less than 1 millimeter square. So light emitting diode is the most visible type of the semiconductor diode. They emit a fairly narrow bandwidth of either visible light at the different colors wavelength. Invisible infrared light for the remote controls, or the laser light when a forward current is passed through them. So LED can produce the white visible light as well as the invisible light and produce the laser light also. So light emitting diode, as is more commonly called, basically it just is specialized type of the diode, as they have the very similar electric characteristics to the PN diode. Then LED will pass current in the forward direction and block the current in the reverse direction. Now you can see on the screen there are different colors of diodes. So light emitting diodes are made up of the very thin layer of the fairly heavily doped semiconductor materials, and depends on the semiconductor material which we are using, the light will emit. So the amount of the doping, the forward bias of the LED will emit a colored light as a particular special wavelength. So no need of the filtering, but the particular semiconductor will produce the colored light by doping the different materials in it. So light emitting diode are made of the very thin layer of the fairly heavy doped semiconductors, and by doping the different amount of the material, then when the forward bias on the LED, it will emit the colored light at a particular wavelength. When the diode is forward biased, the electrons from the semiconduction band recombines with the holes from the valence band, and it releasing the sufficient energy to produce a photon, and that photon will emit the monochromatic of the light. Monochromatic means a single color light we can get. So because of the thin layer of the reasonable number of these photons can leave the junction and radiate away, producing the colored light output. So when we say when the operated in the forward bias direction, light emitting diodes are semiconductor devices that converts the electric energy into the light energy. So another definition of the light emitting diode, that convert the electrical energy into the light energy. So, and it is a semiconductor devices. The construction of the light emitting diode is very different from that of the normal signal diode. The PN junction of LED is surrounded by the transparent hard plastic epoxy resin and hemispherical shaped shell or the body, when protect the lead from the both the vibration and the shocks. So we cover it in the epoxy type of material. So LED junction does not actually emit that much light, so the epoxy resin body is constructed. As you see in the last slide, this is the epoxy body which is also made up of the same color. So, so that will be used for the producing the colored light, that it will enhance the color. So the epoxy resin body is constructed in such a way that the photons of light emitted by the junction are reflected away from the surrounding substrate base to which the diode is attached and focused upwards through the remote top of the LED, and it self acts like a lens concentrating the amount of light which will be released, and that's why the LED appears more brighter at the top because of this epoxy covering. So, not LED are made with the hemispherical shaped dome for their epoxy shell. Some application LED have a rectangular or the cylindrical shaped. It depends upon the use of it. Or the flat surface on the top, their body is shaped into a bar or arrow. So generally all LEDs are manufactured in the by using the two leg producing from the bottom of the body. So how we construct the LED? As we see that we require the p type and n type semiconductor. So we choose that type of semiconductor according to our requirement, which light color output we require. So we drop the material in the semiconductor. So how we construct the LED? The construction of LED is very simple because it is designed through the deposition of the three semiconductor material layers over a substrate. First we use the substrate, then we deposit the semiconductor layer. These three layers are arranged one by one, where the top region is a p type region, middle region is the active, and then is the final, that is the bottom region, that is the n type. So p, then active region, then n region we require in it. The three region of the semiconductor material can be observed in the construction, and the construction, the p region includes the holes and n region includes the electron, where the active region includes the holes and electrons, that is the recombination region. So you can see on the screen, it was easily clear that here we are having the plus and minus holes, holes for the positive and electrons for the negative. So you see charge carriers recombination is there in between that, and different you can see on the right hand side there is a diffused p type, and that is a epitaxial n type material, and one layer of the gold film cathode connection is on the bottom, and both the side, at the upper side we can see that is the metal film connection. Both the side we are having the metal film connection, and the light emission we can get in between that because of the recombination, and it allows a forward and block the reverse biasing. So when the voltage is not applied to the LED, then there is a no flow of the electrons and holes, so they are stable. Once the voltage is applied, then the LED will forward bias. So electrons in the n region and holes in the p region will move to the active region. That in this region, that region is also called a depletion region, because the charge carrier likes holes include a positive charge, whereas the electrons have a negative charge. So the light can be generated through the recombination of the polarity charges. So recombination of the charge carriers occurs in the p type material, and hence p material is the surface of the LED. For the maximum emission of the light, anode is deposited at the edge of the p type material. Anode means negative charge carrier will be deposited on the p type material. The cathode is made of the gold film. As we see that on the bottom we are having a gold film. So that work as a cathode, and the upper side it work as a anode. So it is usually placed in the bottom of the N region. That is that will be the gold. The gold layer of the cathode helps in reflecting the light to the surface. So the gallium arsenide phosphide is used the manufacturing of the LED that will emit the red or the yellow light for emission. The LED are also available in the green, yellow, amber and the red in the color. This is the circuit diagram. As we see, you see again the symbol, that is the LED, that though two arrows are defined here, then it is connected with the transistor and resistance are connected with it. So this is the one type of the LED. The transistor off and on of the LED, we use the base current IB connects the transistor, and the transistor conducts heavily, and then the resistance RC limits the current of the LED. After conduction, the light will come out. The working of the LED depends upon the quantum theory. What is the quantum theory? Which states that when the energy of electron decreases from the higher level to the lower level, and it emits the energy in the form of the photon, and that photon will generate the light. The energy of the photon is equal to the gap between the higher and lower level. That will be that define the working of the LED. You can see on the screen we are having the p type and n type semiconductor that are in the form of the junction p type, and in between that we are having a LED. This is the one of the circuit diagram of the LED, and the forwarding bias are possible. You see that the p type is connected with the positive terminal of the battery, and negative is connected with the negative terminal of the battery. So, and on the lower diagram how the combination of the electron and the holes takes place. You see conduction band and the valence band the bottom, and in between that there is a Fermi level and there is a forbidden gap, and when there is a recombination of the electron and holes, then only in the forward direction, then the light will emit out. You see that this light is emit out. So by using the forward bias, so LED is connected in the forward bias, which allows the current to flow in the forward direction. The flow of current is because of the movement of the electron in the opposite direction. So recombination shows that the electrons moves from the conduction band to the valence band, and they emit the electromagnetic energy in the form of the photon. The energy of the photon is equal to the gap between the valence band and the conduction band. Thank you very much.